Good day everyone, my name is Kato Biled of VS ECE 3A, and today I'm going to present to you my performance task number 4 in ECE 23. The discussion for this performance task will cover pulse code modulation, other variants of PCM, and adaptive delta modulation. Now, what is pulse code modulation? So, it is the only one of the digitally encoded pulse modulation techniques that is used in digital transmission system. Now, I have here additional information about PCM, so you could only look it up by yourself. Now, as previously learned, we have other variants of PCM, and they are 5. One is differential pulse modulation, next is delta modulation, adaptive differential pulse code modulation, adaptive delta modulation, and delta sigma modulation. But our main focus in this discussion will be adaptive delta modulation. Now, ADM. So ADM is the refined form of delta modulation. This method was introduced to solve the granular noise and slope overload caused during delta modulation. This modulation method is similar to delta modulation except that the step size is variable according to the input signal in ADM. So whereas it is a fixed value in delta modulation. So in the slide I present to you the adaptive delta modulation transmitter. Now you see in this transmitter circuit, it is consists of a summer, this is a summer, a quantizer, delay circuit, and a logic circuit for step size control. The baseband signal is given as input to the circuit. The feedback circuit present in the transmitter is an integrator, so integrator generates the staircase approximation of the previous sample. Now with the summer circuit, the difference between the present sample and staircase approximation of present sample is calculated. And then this error signal is passed to the quantizer, where quantized value is generated. The step size control block controls the step size of the next approximation based on either the quantized value is high or low. The quantized signal is given as the output. Now, at the receiver end, that is where the demodulation takes place. So receiver has two parts. So first part is the step size control. Here, the received signal is passed through a logic step size control block, where the step size is produced from each incoming bit. Step size is decided based on present in previous input. Now in the second part of the receiver, the accumulator circuit recreates the staircase signal. This waveform is then applied to a low-pass filter, which smoothens the waveform and recreates the original signal. So here I show you a delta modulation waveform. Now, we start in 0. As you see here, the input signal is greater than the sampled signal, so we will do a plus delta step. 1, 2. From here, we see that the input signal is less than the staircase signal, so we'll do a negative or minus delta step. Next, from here, in this point, we see that the input signal is higher than the staircase signal, so we will do another positive delta step. And in that point, again, input signal is lower, so minus delta step. So in this area, as you can see again, the input signal is greater than the step size or staircase signal. So we're going to do a plus delta step. And that is how our waveform or the delta modulation will generate its output. Now you see the difference in between the original signal and the delta modulation signal says a lot. And what's happening in this big gap right now is what we call a quantization error. And this is what we want to resolve by using adaptive delta modulation. Now, this is just a note, a guide. Now, what do you think is causing the quantization error? That is the granular noise and the slope overload. Granular noise because in this area, we see a positive delta, negative delta, positive delta, and negative delta pattern. While in this portion right here, we only see a plus 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 delta, or in some case, there is a negative negative delta. That is happening. So in this case, there is a slope overload. If this is happening in that case, there is a problem in the quantization of noise. Now, how to solve the granular noise in the slope overload? Decrease the step size and vary the step size depending upon the input signal. Now, ADM, adaptive delta modulation. It reduces the slope overload and granular distortions encountered in delta modulators to a greater extent. In each step of the step size algorithm of ADM, the processor detects the pattern to see if the delta modulation is operating in the granular noise region, in which case it produces an alternating 1010 pattern, or in the slope overload region, in which case it produces an all 1 or all 0 pattern. Now, if the ADM senses a 1010 pattern, it decreases the step size, and if the ADM senses a 1111 or 000 pattern, it increases the step size. Now, different step size algorithms can change the rate of step size in different ways. Now, take note, 1010 is equal as the granular noise in this area, plus delta minus delta plus delta minus delta. They're all the same. And 111 is same as plus delta plus delta plus delta, so on and so forth. Now here I present to you the adaptive delta modulation. In this case now, by utilizing a non-uniform step, the staircase signal has caught up to the original analog input signal. Now, let's go over to the Adm theory. The step size of the staircase signal is not fixed and changes depending upon the input signal. Here, the first difference between the present sample value and previous approximation is calculated. This error is quantized, i.e. if the present sample is smaller than the previous approximation, quantized value is high or else it is low. The output of the 1-bit quantizer is given to the logic step size control circuit where the step size is decided. At the logic step size control circuit, the output is decided. If the quantizer output is high, then the step size is doubled for the next sample. If the quantizer output is low, the step size is reduced by 1 step for the next sample. Here I present to you the adaptive delta modulation advantages, so it's up to you to tackle because we don't have enough time. And the difference between adaptive delta modulation and delta modulation. Now, in delta modulation, step size is fixed for the whole signal, whereas in adaptive delta modulation, the step size varies depending upon the input signal. The slope overload and granular noise errors which are present in delta modulation are not seen in this modulation. The dynamic range of adaptive delta modulation is wider than delta modulation. Now, this modulation utilizes bandwidth more effectively than delta modulation. Now, here I present to you again the applications of adaptive delta modulation, and it's up to you to read. This modulation encodes 1 bit per sample, and this modulation method compromises between simplicity, low bit rate, and quality. This modulation method was first published by Dr. John E. Abate in 1968. A good amount of work has been done in this area using song and modified Abate step size algorithm. This modulation is the first step in the conversion of the analog signal to a digital signal. The next step is the representation of this digital signal in mathematical form, for which digital multiplexing techniques are introduced. But we don't have enough time to explain the tedious parts of ADM, adaptive delta modulation. I could have explained to you the song and modified Abate step size algorithm operation and introduce the mathematical equations in this algorithm and compare the performance between the song and Abate algorithm. So, that's all for today's discussion. Thank you.